So in this problem, I need to find the extreme values and where they occur. So I like to start these problems by figuring out what is the domain of the function. And to do that, I'm going to look at my don't ride lions. So denominator, radical sign, logarithms. Criteria to see if I have any domain restrictions. Well, I don't see any denominators in this function, and I don't see any logarithms. But I do see a radical sign, and that radical sign has an even index. It's a square root. The index is assumed to be 2. So if I have a radical sign with an even index, the radicand, the part underneath the radical sign, has to be greater than or equal to 0. So I'm going to set 3 plus 2x minus x squared greater than or equal to 0. This is a polynomial inequality. So I'm going to take you back to pre-calculus or algebra 2, and you can kind of remember how those work. First of all, I don't like this in this format because I have this negative x squared. It's all backwards to me. I'd rather have it in standard form. So I'm going to multiply both sides of this equation by -1. And I'm going to end up with x squared minus 2x minus 3. And you remember, when you multiply or divide both sides by a negative, you got to flip the inequality sign. So less than or equal to 0. So this is telling me, I'm going to factor this, and I factor it, I get x minus 3 times x plus 1 is less than or equal to 0. Now, a brief review of polynomials. Here is a graph of a polynomial. And when I say that the polynomial is less than or equal, this is not this polynomial, but it's a polynomial. When I say that a polynomial is less than or equal to 0, I'm talking about the y values being less than, or in this case, equal to 0. So that point would be included, that point would be included, that point would be included on this polynomial, which again is not the polynomial that I'm talking about right now. I'm just making an example. Because the thing I want you to notice is that the y values on this polynomial, and let's call this polynomial f, here they're negative, here where I've made a label in black, they're negative, and the only place they can turn to positive, they can change from negative to positive, is right where the polynomial crosses the x-axis. That's the only place they can possibly change. I mean, if my polynomial is down here, and I can't change from negative to positive there, I still have to go all the way to the x-axis. So the only place they can change is where y is equal to 0, is where my value of x produces a 0 y. That's important, because that's the only way we can really determine the domain of this polynomial that we're dealing with, because I have to make sure that the radicand is greater than or equal to 0. That's why I'm doing all these calculations. So what I need to do is this. I need to draw a number line. And here's 0. And I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I know that my zeros in this particular inequality are going to happen at +3, so I might put a line right there at +3, and a -1. And I put a line right there at -1. And I can only change from positive to negative on my y values at those x values right there, 3 and -1. So in order to determine whether the value of this polynomial is less than 0 or greater than 0, all I need to do is test a number in each of these 3 segments. So let's test a number. Well, I always like to start with easy numbers, so I'm going to test the number 0 for x. So that would mean I would have 0 minus 3 times 0 plus 1. And I want to know, is that less than or equal to 0? Well, this gives me negative 3 times 1. Well, that is negative 3. That is less than or equal to 0. So in this segment right here, it is true that this polynomial here is less than or equal to 0. Let's test another number. Let's test the number, well, we want to go into this segment over here. So let's test the number, well, let's test the number negative 2. So I go, no. Yes, negative 2 is okay. So I go negative 2 minus 3 times negative 2 plus 1. Is that less than or equal to 0? Well, this gives me negative 5 times negative 2. No, negative times a negative is a positive number. So it is false there. Let's try a different number. Let's try a number now in this segment over here. Well, it has to be greater than 3. Let's try 5. So I have 5 minus 3 times 5 plus 1. Is that less than or equal to 0? No. This is going to be a positive number. That's going to be a positive number. Positive number times a positive number is a positive number. It's greater than 0. So it's false over here. So what I have just done is I have now determined the domain of this function. And the domain of this function is negative 1 to positive 3. So the domain of this function is negative 1 to positive 3. It's with brackets. It's included because it says less than or equal to 0. So that is the domain of my function. So I'm going to start us off on a new clean page, and I'm going to make sure that I know that my domain is negative 1 to 3 inclusive on this function. Now I can get started and try and find the derivative, because now I have my domain, and I want to find out, well, do I have any critical points? And of those critical points, are any of them stationary? So let's find the derivative. I'm going to change this into y equals, well, I'll go 3 plus 2x minus x squared, and I'll call it to the 1/2 power. And I'm going to go y prime is equal to, well, 1/2 3 plus 2x minus x squared to the negative 1/2 times the derivative of the inside, which is 2 minus 2x. So I'm going to simplify this now. Y prime is equal to, well, I have a negative exponent. So I'm going to say y prime is equal to 2 minus 2x, that's going to be on my top, divided by 2, that comes from this 1/2 here, times 3 plus 2x minus x squared to the 1/2 power. I'm going to simplify it just a little bit more. I'm going to go y prime is equal to 2 times 1 minus x over 2, and I'm going to turn this into a radical sign right now. 3 plus 2x minus x squared. And I'm just doing that because I prefer it, when I'm at this point of a problem, and I know I'm going to have to find the domain of the derivative. So these 2's cancel out, and my y prime is equal to 1 minus x divided by the square root of 3 plus 2x minus x squared. Now the whole reason I'm finding the derivative is because I want to find my critical points. I want to find my critical points where the derivative is either equal to 0 or where the derivative does not exist. Well, I can see that the derivative is equal to 0 where x is equal to 1. because if x is equal to 1, my numerator becomes 0, and that's going to make my derivative 0. So x equals 1 is critical and stationary, because the derivative is equal to 0. But I also can see that I'm going to have some x's in my denominator that are going to make it equal to 0. And if you remember, we just factored this whole thing out, and we found out that this factors into x minus 3 and x plus 1. So if x equals 3, this is going to be equal to 0. If x equals negative 1, this is going to be equal to 0. And I will have a denominator that's 0. I'm not allowed to have that. So where x is equal to negative 1 or 3, I have a critical point that is not stationary. Because the denominator equals 0. The derivative y prime does not exist. It is undefined. So if you recall, the domain of my function, so the domain of y, was negative 1, 3 inclusive. But my domain of y prime is just negative 1, 3 not inclusive. So this is the domain of the derivative. So I found my critical points, one of which is stationary. So I know that my extrema can only happen at critical points whether or not they are stationary. And that is going to be, one of them is going to be x is equal to 1, which came from this making the derivative 0. So x is equal to 1. I could have extrema at the endpoints, which are negative 1 and positive 3. Now, even though there's no derivative there, they still do exist in the function, because the derivative, the domain of the function, includes negative 1 and 3, so we need to check the endpoints as well. So let's find out what are our y values here. Well, my function again is the square root of 3 plus 2x minus x squared. So let's find out if we find this is f of x. So let's find out what is f of 1. Well, f of 1 would be equal to the square root of 3 plus 2 times 1 minus 1 squared. So that's equal to the square root of 3 plus 2 minus 1, which is equal to the square root of 4, which is equal to 2. So I have one point that's possible extrema at 1, 2. What about f of negative 1? Well, that would equal the square root of 3 plus 2 times negative 1 minus, now be careful here, it's negative 1 squared. So that is equal to the square root of 3 minus 2 minus 1, because negative 1 squared is 1. So that is equal to 0. So I have another possible point right there at 1, 0. And now let's find f of 3. So I want to find f where x equals 3 is equal to the square root of 3 plus 2 times 3 minus 3 squared. That's equal to the square root of 3 plus 6 minus 9. Well, that's also equal to 0. So I have another, my endpoint is 3, 0. So those are the only points on this function where I can possibly have maximums or minimums. And I can see right off the bat that this one right here is going to be a maximum, because my y value is the highest of all the points. My endpoints, which are, so this is a critical and stationary. This was just critical. This was just critical, but these were also endpoints. Endpoints. Because our domain of the function was this right here. Well, if you recall, endpoints, almost by definition, not quite, are going to be some kind of maximum or minimum. Because if I have a function, I don't know what this particular function looks like, but let's just draw a function like that. This is an endpoint, that's an endpoint, and the definition of a maximum or minimum on the interior says, well, all the points to either side of a maximum or minimum have to be greater than or less than that particular point. But that's on the interior of a function. On the endpoint of a function, just all the points on one side of it have to be maximum or minimum. And I mean, I can't think of a function that has an endpoint where everything else is in either higher or lower. So the endpoints are also going to be maximums or minimums. And in this case, because I already have my maximum, the endpoints are going to be relative or local minimums.